sisters. Hi, sisters.
Y'all don't sit down, bruh. Come on now.
Okay, so now we have to finish 6.2.
Hey, that's me.
We're going to finish 6.2 today by working with rationalizing the denominator and doing all of that fun stuff.
You are.
Okay.
You can go ahead and say something.
Okay, properties of radicals. Okay, we talked about this yesterday too, but you've got to be able to start moving properties back and forth so that you can work with the numbers you need. If I have the nth root of a times b, I can separate it to take the nth root of a and take the nth root of b and then multiply them together. If I have a number such as the nth root of 9 times 12, or let's say the square root of 9 times 12. Does 9 have a square root? Yes, which is 3. Does 12 have a square root? No.
But it has 4.
But it has 4, so I can take a 2 and leave a radical 3 in there, right? So my answer would be 3 times 2 radical 3. You're going to break it apart so that you can separate it as far as you can go, okay? If I have the square root of 9 times 16, okay? I'm going to break it apart, take the square root of 9, which is 3, take the square root of 16, which is, and multiply them together to get my answer. Instead of having to recognize that there's a perfect square of whatever 16 times 9 is. Do you get what I'm saying? You can break it apart into numbers that you can work with or that you recognize easier.
Got it.
With both multiplication and division. And in division, we have to break it apart because we can't have a radical in the denominator. So you have to rationalize the denominator. Okay, so we're going to practice a bunch. I have the fourth root of 27 times the fourth root of 3. Now here's the problem. We talked about this a little bit on this problem behind me. 27 and 3 are not the same numbers in there. So I can't multiply them together. But what can I get 27 down to a base of 3?
Yes.
How?
Take 9 and 3 out.
Okay, and then what does 9 break down into?
3 and 3.
So I have how many sets
3
of...
to the third.
Okay, so I have this. I have the fourth root of 3 to the third. I can write it that way, or I can write out the fourth root of 3 times the fourth root of 3 times the fourth root of 3. Whichever way you see it. Anna's way is a little quicker. If I write the fourth root of 3 cubed times the fourth root of 3, what do I end up getting?
3 to the 4. The fourth root of 3 to the 4.
Which gives me what?
3.
Because I have how many sets of 3 inside? Or how many 3's do I have inside? 4, and I need a set of 4 to take it out. Okay? Now, look at number 7. You have the cube root of 250, and you have the cube root of 2. What do you think I want to break it down to?
125 and 1.
What?
If I have a radical on the bottom spot, the cube root of 2,
You have to flip it.
you think I do either have to multiply by it, or an easier way is to first see if the top can be broken down with a 2 so that maybe it will cancel.
125.
Okay, so does 2 go into 250?
Yeah.
And it gives you what?
125. That's
So
a
I
lot.
have the cube root of 2 times the cube root of 125 over the cube root of 2. What's going to happen there?
Those cancel out.
These cancel, leaving you with the cube root of 125. Does 125 have a cube root?
Yes.
What is it?
5.
And there's my answer. Okay, here I have the fifth root of 3 over 4. Does 3 have a fifth root?
No.
Does 4 have a fifth root? No, so this is where I have to do some stuff.
No.
So I'm going to divide it to say this. I'm going to divide it into these segments so that I have the fifth root of 3 over the fifth root of 4. Now, to get rid of a fifth root, how many numbers do I have to have inside?
5.
5 of the same. Right now, how many do I have down there with the fifth root of 4? So what do I need to multiply by?
4.
Sort of, yes.
Yeah.
I need to multiply by the fifth root of 4 to the fourth, because when I multiply the same bases with powers together, it adds the power. What is my power right now with 4? 1, so I need 4. So I have to multiply by the fifth root of 4 to the fourth and the fifth root of 4 to the fourth. Because when I do this up top, I'm going to get the fifth root of 3 times 4 to the fourth. I can put them under the same one since they're both the fifth root. And on bottom, I'm going to get the fifth root of 4 to the fifth, because 1 plus 4 is 5. What happens now? You're not done yet. Up top, you're going to have the fifth root of, what's 4 to the fourth?
4 times 4 equals 16 times 4 equals 64.
256.
Okay, and 256 times 3, because that's still in there.
768.
768. Over what number?
I think that concussion
4,
popped your
yes.
brain back.
Now, here's the problem. I need to now break 768 down. I need to see if there's groups of 5 that I can take out of there. Okay, so 768, factor tree. What goes into 768?
That's a good question.
You know 3 and what? What was 4 to the fourth?
256.
6.
256. So we know that 3 and 256 go in. What do you know about 256?
14.
It's an even number.
16.
What, 16 is the square root?
Yes.
So I have 16 and I have 16. What goes into 16?
4 and 4.
4 and 4.
2 and 2.
4 and 4, right? 2s. 2. Okay, do you see how I'm breaking this down into all the prime numbers? We have to have prime numbers, remember that. Now, I need sets of 5. I have 1, 2, 3, 4, 5 2s. Yes? There's one set. So I can bring that out to have 2, the fifth root of. Now, I don't have another 5 of 2s, do I?
No.
And I have a 3 still, so I have to multiply these back together. 2 times 2 times 2
8.
times 3,
24.
and that's what's left on the inside here over 4. Now, they're not going to stop there. Why are they not going to stop there?
Cause they're
No,
Oh.
I can't do anything with that fifth root. That's off limits now. Because the 2 and 4 reduce to 1/2. So they're going to write their answer as the fifth root of 24 over 2. That's how you're going to see the answer. Okay? You have to take it down to prime numbers. If you do not take it down to prime numbers, you are not finished.
Yikes.
Like the bottom side number?
Everything that's in a radical has to be broken down into primes, and if you cannot take numbers out from there, then it's whatever number is left over. Okay, that's left. So let's say it didn't say 768, let's say it said 769. Okay, prime number wise, that's not going to break down. It might break down into, let's say it breaks down into 27, no, let's say it breaks down into 17 and 3, 2 other prime numbers. I can't take groups out of that, right? So I just leave it multiplied together in there. But if it breaks down, you've got to take everything out that you can. Now, I personally think it's harder with numbers. We're going to do it with letters in a minute. I'm going to show you why it's easier with that. Okay? Here I have the cube root of 5 plus the cube root of 40. Can I add those together?
Yes.
no.
No, I can't. Because the
Buckle.
insides are not the same. They're not both
Oh, but
5.
you can break it down.
Okay, what can I break down, Anna?
8 and 5.
8 and 5 is 40, okay? 8, is 8 a cube?
No.
Yes.
Yes, what is the cube of it?
2.
So technically, this breaks down into the cube root of 5 plus 2, the cube root of 5. Right? So what is the cube root of 5 plus 2, the cube root of 5? What is x plus 2x?
3x.
So what is the cube root of 5 plus the cube root of 5?
3.
Yeah.
5 cubes.
3, the cube root of 5. So in order to add or subtract or anything like that, divide, I have to have the same thing inside my radical. If not, I got to break it down. Okay? Okay, so then this basically is telling us, hey, This rule applies to numbers and to letters. It also applies when something is odd and when something is even. When it is odd, okay, I am going to have whatever the root is come out to be. Like, so if it's the nth root of x to the n, I get x. If it's the 7th root of 5 to the 7th, I get 5. If it's the 7th root of -5 to the 7th, I get -5. Because remember, on odd roots, you can have negatives inside. Can you have negatives on even roots?
Oh.
No, because I have imaginary numbers then. Okay? So if it's negative, they're basically telling us you have to take the absolute value of it. You can't have a negative output. Yes,
Okay, so basically, the odd and even only applies to the exponent.
to the exponent. Okay. To the radical. Yes, the radical. So then we get stuff with letters.
Lord Jesus.
No, listen. This to me, this is so much easier. Okay, cube root of 27, q to the 9th. Let's start with one thing at a time. Start with the number, 27. Does it have a cube?
Yes.
Yes.
What?
3.
So I take a 3 out of there.
Yeah.
Okay? Now, q to the 9th is asking me, how many times can 3 go into 9?
3.
There are 3 sets of them. So I'm going to have q to the what power on the outside?
I'm not gonna say anything. Oh my God.
And that's a perfect cube
That's it.
root. That's it. Okay?
That's an easy one.
Now, here, I'm taking the 5th root of x to the 10th over y to the 5th. Does x to the 10th have 5th roots? How many sets of 5 are in 10?
2.
2. No left over, right?
Yeah,
So I take out an x what?
to the square.
An x squared. Good. Now, that's over top of how many sets of 5 are in y to the 5th? So I have a what taken out? A y.
Okay.
Okay, now we start again. First, we start with our numbers, 6 and 3. Do those reduce somehow?
Yeah.
What happens?
2.
2 and 1.
Now look, x over x to the half. What do I know about exponents there?
2.
Subtract, so what's 1 minus a half? So I get x to the 1/2. Now I have y to the 3/4 minus y to the half. What do you get?
Why 1/4?
Not
To
1.
the 1/4.
No.
I don't even know.
3/4
Oh, to
minus
the-
1. Oh, wait a second. Yes,
Yeah.
3/4 minus 1/2 would be 3/4 minus 2/4, right? So 1/4. So you get y to the 1/4. Answer.
Wait, you said that.
Okay. 9, I have the square root of 9w to the 5th minus w square root of w cubed. Let's start with 9w to the 5th. Does 9 have a square root?
Yeah.
What is it?
3.
How many sets of 2, groups of 2, can I take out from w to the 5th?
2.
2. So what's going on the outside?
W to
No.
the 4.
No, not w to the 4.
Just W.
W squared, because I took out 2 sets of w. So what happens is this. I say draw it out if you need to. Okay, I took 2 out, 2 out. That's what gave me the squared. How many do I have left inside?
W.
Oh, why did I put... I'm going crazy, I'm sorry.
You and me both, 'cause Lord Jesus.
So I put w there, okay? Now, look over here. I have w cubed, right?
Yes.
And I'm looking for what? What's that root?
To the third.
What's the radical?
Oh, what?
No. 2, the square root. So how many do I need to take out? 2. So I can take out 1 set, right? On the outside, there's already a w. So what's w times this w I'm taking out?
W to the 6.
Yeah, w squared. And what's left on the inside?
W.
Now, can I subtract those now?
Yeah.
Yes. What's 3w squared? 3w.
squared.
Okay, it's what?
2W.
2w squared radical w.
Yes.
Wow. That's not the one where like
I don't like
you
this
combine
either.
like terms.
Oh, okay, I see. Okay, that's what you're working on in your homework tonight. Okay. Get busy.
This is stressing me out so much.